И сегодня я расскажу про разработку сервиса доступа и управления интегрированной базой уязвимостей. Итак, почему же возникла такая задача совместить данные из разных баз в одну интегрированную базу? Это отсутствие единого формата представления, несогласованное размещение данных в базах уязвимостях, в основном открытых, и отсутствие открытого доступа для автоматизированной работы с базами. То есть все данные, которые предоставляются в открытом доступе, они содержатся в HTML веб-интерфейсе. Задача, которая стояла перед нами, это интеграция информации об уязвимостях, интеграция записей продуктов и проектирование структуры баз.
Sorry. Integration of information about the challenge that we had, integration of information about the vulnerabilities, development of service, of success, and management of integrated vulnerability base. The task is very important because it's aimed to systematize data from different sources, normalize, systematize the formats, provide good access, and increase of precision and accuracy of defining products having vulnerabilities through better configuring of information. In this slide, we have model of setup that integration is made on the reference links from different bases one to another. That's identifiers of the used bases and other links. And we have cross-reference with that primary and secondary. And then in the future we get in the output integrated list of vulnerabilities. As the main sources we've chosen the following bases: CVE, National Vulnerability Database, OSVDB, and Xforce from IBM. As a research of the database, we've found this comparison. We have the links to the CVE and OSVDB with number of unique links, those which are used one time, multi-time, one time. This graph you can see that mainly bases refer to one to another, used unique links, so they are smooth compliance between one another, and some errors, of course. This graph you can see the model of integration of records of products on which in the future we're going to have the selection, setting up the result about having vulnerabilities in the proposed configuration. This configuration is shown at the input of the system, and then there's a search for the records, product records, and then under the records of product records there's a search of vulnerabilities in these products. There was a following structure designed which contains 5 tables. Table of connectings between products and vulnerabilities, producers, products, and product records, which contains type of products, version, modification, and edition. ECP 2.2 version was taken as a basis, but some of the fields were removed because the language, location, because the value of these fields cross between each other. So if in one record there's Russian language version of the product, another refers to its modification. This structure allows to make selection of vulnerabilities and product records in one request, and also through the dependency parameters it is possible to quickly define vulnerabilities having only 2 products in the systems, and through that parameter we can see whether this product is vulnerable completely or only if it has another product. So that's the example on the slide of the record dependency. The first configuration, realization of vulnerability product 1 and 2 is simple. And second configuration 3 and 4 depends on having products 5 and 6. Therefore, in the table, it is shown that parameters of balance in first configuration 1 and second products is equal 0. For 3 and 4, it's 1. For 5th and 6th, it's 2. I mean, dependency parameter is 2. So we clearly define whether products are linked to each other or no. For the 0, there's no dependency. For 1, there's only one group of dependent products. And for the 2 parameter dependent, these products are dependent. We have resolved the following challenges: establishing integrated vulnerability lists, product dictionary, integrated product dictionary, web interface to access database, and also servers of the program access through WSDL. Why we need that? Of course, we decided not to stop at the integrated vulnerability database, and at the end, we are implementing integrated information storage. The components of the storage is that it contains records of products, vulnerabilities, and exploits. Exploits are sold for money. They're not in open access, but they show products that exploits are relevant to, and could be some details of implementation. This factor allows to understand that in our system having certain product, there's a paid exploit, so there's a threat of using this product. That is a model of access to the data in the warehouse and data storage. And the input, there's products, they're identified from the integrated list of products, and under the identifiers we have a record and search of vulnerabilities in the integrated vulnerability base, and then on the vulnerabilities identifiers we can see which exploits exist for these products. In the slide we see architecture, which is a module realization. That's the loading module, base itself, and web interface to connect with remote clients. So in the beginning there's loading of used sources, then loaded data get into the setup module. After that they have the base, and then this base could be used. It is all could be seen by the security administrator of the web interface, both loading and setting up and the results of setting up, and they can see and define whether the database must be updated or not. There's an automatic update from all the requested sources, and then there's a result. Result could be obtained through the WSDL service in the manual mode, then setting up the configuration. In this slide we can see the example of requests. And having vulnerability lists on the product lists. In this example, product 1, product 2, which are checked for having the value dependency 0. And the result of this request is getting information about the vulnerabilities. And see the example of visualization of integration of the product records in the LCP dictionary. Blue are loaded data. Initially all the records of products records blue, then dark blue integrated with other bases. Red are products which were relevant with the vulnerable products and vulnerability bases, and dark predefined records says because products sometimes are renamed from time to time, accompanied by each other, and the records are changed again. Products are indeed the same. As a result of setting up the base, we have the following results: integrated list our vulnerabilities contain 85,000 unique records. With relations with the X-Force 45 and other fields, and comparing with the unique records and products with the NCP dictionary resulting database, we had more than 200 product records versus other databases, much higher. And in terms of costs on setting up used databases, consumption of resources was not so high, and time of setting up the result for the configuration was 58 particles per second. In the future development, we want to add other components into the integrated storage of information, which are the configuration records, weaknesses records, and attack templates records. Extension of vulnerability database and product dictionary through better quality definition and databases that has no format of presenting the product records, and also translation into CVRF. There's a format, but so far there's no access to that. That's not completed. Thank you very much. Your question. Hello. Who do you think who's the main audience for consuming of your products? The database is developed for the automatic analysis of securities, so we're going to use ourselves first because we are developing the system. Protecting against what? Against infrastructure, networks primarily. We have information about configurations of products at the once we pass basic configuration from the database, we see what vulnerabilities they have. Let me explain my point of view. I've been into that for several months myself as a developer. Because the problem in CVE is that when you integrate the components, software components, if you have not a product like Windows, I don't know, CAD 7.0, but if you have the application which uses the software component libc or Java component of any versions, whatever, but that path is not laid. Several commercial companies are developing this, but this service requires a lot of investments and money. There are some open products victims that Red Hat work with, and others. So far, they are give very little percentage, low percentage. Do you have any ideas about how to move this way to help developers? Because if in the infrastructure there are applications that somebody already developed, your analysis will give nothing or give very little. You mean vulnerabilities in the plugins, or you mean vulnerabilities in plugins, or what? In the libraries, for example. Okay, I understand. In the CVRF format, which I have shown in the end, not just the version and the name needs to be mentioned, but also patches as well. What modules are touched by these patches? If we have this dictionary, we don't. Yeah, it's manual work. You cannot do it automatically, right? Main purpose of your product is to help administrators. Now, the main purpose is to make it automatic, not just the administrators check all the databases manually, but rather make a process automatic to search for vulnerabilities on the product lists. For every model, there is the software which collects data about installed products and then simply get it and they bring it to the analysis system. What I wanted to say is going to work for big box products. If you have any applications that were developed using standard setup vulnerabilities, there's possibilities of false negatives. When there's a negative, when there's a vulnerability, could be identified with these scanners. Vulnerability scanners, it could not be identified through automatic methods because it's not quite precise. Possibly. Oleg Kashov, BIS expert. Tell me please. There's a CAPEX standard tag template and there's also in Russia database based on stack. There's a threads base. Can we say any link between the standard and the threads? Stack database was issued recently. That's clear. Lutikov said yesterday that they are going to classify this thing, but they said it's going to be in 2016. Would it be realistic based on this Mitrov's standard to build up the description of these threads and then link them with vulnerabilities? Can you integrate your universal base with their vulnerabilities base? If we have any identifiers or cross-links or sources or exploit, at least for the products, of course we will be able to integrate that in the future. As soon as they have their own format, we'll need to see. Then, yes, of course, it would be great. Can I ask another question? First one, product configuration. I'd like to find out in which format to do that. CPE 2.2. The list of products is sent to the modules of processing. There are some utilities that, yes, sure. And about CWE, how do you plan to use that? Weaknesses, yeah. In the CWE, there are references not to all the vulnerabilities, but to weaknesses. So, it's more for classification purpose, or they have some unique records. In CWE, there's the identifier, so it's possible to link. Okay, thanks. But number of vulnerabilities in the software. Can you show the slide? Unique record, product records, number of products. How can you evaluate records which are shown in your database? Pardon me? Number of software products. That's the result. 22,000 records. You mean softwares? Yes. When we talk about tens of thousands of software products, valuable products, is it for experts? No. It is for experts. They have web interface and for automatic access, SDL service. When we're talking about tens of thousands of records, product records, we need to systematize that, bring this into order. These details haven't resolved this problem yet. they have same product could be represented under different names, and we have infographics in different way. So in order to get reliable information about vulnerabilities, you need to work hard with this database. Are you planning to have any record systematization about vulnerabilities, for example, to open it up to see if there are less vulnerable products? You understand? For each and every product producer, we give its own identifier. So if we bring together products or merge products in CPE, there are certain products like that. And we have a separate producers table if we want to see which products are vulnerable of that particular producer or vendor. We make example. If I'm not mistaken, we had about 1,500 producers with product, about 15 or 20,000. All 22 product records are processed manually? No, no. How do you guarantee that there's not duplicated records? We compare manually? No. Automatic? How? On the loading stage, load the data, compare with the data that are already available. A small error in the record producer was called like this: human error in a text. I mean, there must be intellectual analysis of vulnerability data because the volume is quite high. If a person needs to work with that, this person will not be able to analyze this lot of amount of data. So far, we do not process the errors. Thank you.
Сервис будет доступен через веб-интерфейс.
Is it going to be available through web interface? It is currently available through, to me, yes, to me. But we haven't put it into open access. Are you going to do that? Yes. Are you planning to do any monetization of the service? No. When we are going to find out about the launch of the service? As soon as we launch it, we will inform it. Thank you. Thank you for your attention.